All right. So we are looking at 3.3 characteristics of polynomial functions in factored form. So it says roots of order 1. The graph has a linear shape near the x-intercept and it passes through the x-axis. What does it mean? So if you have in factored form, okay, so you are going to look at the exponent of each factor. If the exponent is 1, then we call them order 1, okay? In this case, the first example, all the factors have power of 1, so they are all actually order 1, okay? But when you look at this example, if we have x plus 5 squared times x minus 1 times x minus 4, okay? So, for example, this factor has a power of 2, right? So that factor has order 2. And these two order 1. Powers are 1. When you look at this example, so we have x plus 6 cubed as one factor. So you look at the exponent, that is 3, so that is order 3, okay? And this is order 2 because the exponent is 2, and this is order 1. Okay, let's go back to this order 1. So, so if the factor has order 1, and the x-intercept, you will have an x-intercept, let's say here x equals -2, right? Then the graph has a linear shape near that x-intercept, and it passes through the x-axis. So if we needed to sketch this function, okay, so a value is accepted as positive in this case, and previously we looked at this, right? So we see that odd functions with negative leading coefficient goes from quadrant 2 to 4. Odd with positive leading coefficient goes from 3 to 1. Even with negative leading coefficient goes from quadrant 3 to 4. And even function with positive leading coefficient go from 2 to 1. So if this is so, you have each one has exponent of 1. So at the end, we are getting a cubic function here. So if we have a cubic function with positive leading coefficient, okay, so this is going to be it, right? So you start from quadrant 3, go to quadrant 1. So you start from quadrant 3, so you put your x-intercepts, you have -2, 2, and 5, -2, 2, and 5. So as you reach the first x-intercept, you check the order. If it is order 1, you just pass through. So this is called linear behavior.
Miss, I have a question. So, like, what does it mean by oh, never mind. You're doing that right now. Never mind.
Okay. So linear behavior. So you just pass through the x-intercept. Okay. Then you go to the next x-intercept because it has order 1. So again, you pass through, and this is called linear behavior. Then you reach the next x-intercept and you pass through, and you start from quadrant 3 and go to quadrant 1. So let's look at order 2. Okay, so we see that x plus 5 has order 2. The graph has a parabolic shape near the x-intercept. The x-intercept is a turning point. The curve does not pass through the x-axis. Okay, so for this function, -5, +1, and 4 are the x-intercepts. So -5, +1, and 4 are the x-intercepts of this function. So, but again, so this is if you look at the degree of this, so 2, 1, and 1. So this is degree 4, right? And then I'm telling you that A is positive. So you know that this graph should go from quadrant 2 to quadrant 1. So you start from quadrant 2, you reach the first x-intercept. You check the order. It is 2. Then there's going to be a parabolic behavior around that x-intercept. So you reach it, but if it was linear, if it was order 1, if this was order 1, then you would just pass through it. But that's not what it is, right? Because it is order 2 here, then you bounce off the x-axis. Okay, and this is called parabolic behavior, because remember, around the vertex for the parabola, this is the behavior that it has, right? That is the reason. Then look at the other two. So x equals 1 and x equals 4, other two x-intercepts. So when you reach the next one, order 1, pass through, linear. Then you go to the next x-intercept, again, order 1, pass through, and sketch it. Let's look at order 3. Okay. The graph has a cubic shape near the x-intercept, and the curve passes through the x-axis. First of all, what does it mean having a cubic shape, right? So therefore, I'm going to kind of remind you how y equals x cubed looks like, okay? So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. And when x is negative 1, y is negative 1. When x is negative 2, y is negative 8. If you sketch this, this is what you get. So as you see, I like a upside down parabola here, and this is the like regular open up parabola, this piece. So this is called cubic behavior. So it means when you have a factor with exponent of 3, then the graph around that x-intercept will behave like this, okay? In this case, we have x-intercepts at negative 6, 1, and 4. So negative 6, 1, and 4. Okay, those are the x-intercepts. Then this degree is 3, 2, 1. In total, this degree is 6. A is positive. Okay. Then you know that you're going to go from quadrant 2 to quadrant 1. All right. And then you start from quadrant 2. You go to the first x-intercept. Okay. You reach negative 6. Then check the order. It is 3. Then you know that you're going to have a cubic behavior. So it's like parabola opens up, parabola opens down. Okay. So you make that shape. And during the evaluation, make sure you kind of exaggerate this so that I can differentiate the cubic behavior with linear behavior. Okay. So you do the cubic behavior. Then you go to the next x-intercept, which is 1. That factor has order 2. Then you are going to do a parabolic behavior around that x-intercept. And then you go to the next x-intercept, that is order 1. So it is just linear behavior. You just pass through 4. Okay. So using this information, we are going to do a couple of sketches. Okay. The first one, we have x plus y equals x plus 1, x minus 1, and x minus 3. So sketch a graph of the function of this function showing x and y intercepts. Okay. So x intercepts. So you get negative 1, 1, and 3. Y-intercept, you calculate. So substitute 0 for x. So you get 1, negative 1, negative 3. Multiply all of them, you get positive 3. Okay. Y, x. All right. So negative 1, positive 1, and positive 3. We also put the y-intercept, 3. Now we're going to sketch, but we need to also decide if it is an odd or even function and if the leading coefficient is positive or negative. If you multiply all of this, you see that they all have power of 1. Then the leading term will have x to the power of 3, x cubed. Okay, so this is an odd degree. Again, if you were to multiply all the brackets, the leading term would be x cubed, 1x cubed. So the leading coefficient is positive. Okay. So then you remember this. Odd function with positive leading coefficient. It starts from quadrant 3, go to quadrant 1. So starts from quadrant 3, go to quadrant 1. Okay. And then we go, reach the first x-intercept, check the order. Oh, order is 1. So I'm just going to do a linear behavior. Okay, here. Then I need to pass through the y-intercept. Then go to the next x-intercept, which is +1. The order is 1, so I'm going to just pass through, do the linear behavior. Okay, and 3 linear behavior as well, because exponent of that factor is 1. And we are done. Example 2.
Miss, could you show example the 1 again? Could you show
Sure.
it for like 5 seconds?
Sure.
Yeah, thank you.
Why isn't x plus 6? X plus 6. Do you want this question? But see, this is not the only factor. Okay, the degree is not 3 here. The degree is not 3 here. There is this, and that. If you expand all of these brackets, you get the highest the term with the highest exponent will have x to the power of 6. So that is degree 6. Therefore, it cannot go from 3 to 1. So you end up with an even degree. Therefore, it goes from quadrant 2 to 1. Okay. If this was only y equals x plus 6 cubed, that's another story. Then yes, that would have an odd degree with positive leading coefficient. Then the graph would go from quadrant 3 to quadrant 1. Does that answer your question? Okay, let's move on. So sketch a graph of the following function. So we have y equals x plus 2 squared times x minus 1 times x minus 4. We are also, going to find x-intercepts and y-intercept. Okay, x-intercepts. So we have -2, 1, and +4. So y-intercept, calculate. When you substitute 0 here, you get 2 squared. You have -1, you have -4. So when you multiply, you get 16. Okay. Then we sketch. Put the x-intercepts, -2, 1, and 4. Put the y-intercept, 16. Then decide for the degree and the leading coefficient. So you are getting x squared from this bracket, x from this bracket, and x from this bracket. If you multiply all of this, you get x to the power of 4, which is an even degree function. And again, if the leading coefficient is x to the power of 4, then you get a positive leading coefficient here. Okay, even with positive leading coefficient, this is the case. You start from quadrant 2, go to the quadrant 1. Okay, so we start from quadrant 2, go to the quadrant 1. Okay, first x-intercept we see -2. Check the order, 2. So we need to bounce. Okay, then we are going to go to the next x-intercept. The order 1. So we need to just go and pass linear behavior. Then we are going to the next x-intercept, which is 4. Order is 1. Again, linear behavior, just you pass through. and finish your graph. Let's sketch the next one. Okay, so again, we are going to find x-intercepts. -2, 1, 3.
Wait, Miss Tass, I have a question. So for
Yep.
example 2, right? You know when you pass the negative, when you pass the 1, when you go through the 1, yeah. How do you know how like down to go?
You check the exponents.
Yeah, but how down on the y do you go?
How down? Oh, that doesn't matter.
Oh, it doesn't matter? Oh, okay.
Yeah. Okay, so -2, 1, and 3 x-intercepts. Now let's look at the y-intercept. So we substitute 0 for x. So you have negative sign, you have 2 cube, -1, and -3. So 2 cube is 8. 8 times 3 is 24. There is 3 negative signs. That gives you -24. So -2, 1, and 3 x-intercepts. And let's make this one -24. Okay, so check the degree. 3, 1, 1. So degree of 5. Okay, leading coefficient, negative. Okay, so you check odd degree with negative leading coefficient goes from quadrant 2 to quadrant 4. Okay. So quadrant 2 to quadrant 4. Then we start quadrant 2. So first x-intercept, -2. Check the behavior, right? Order is 3. So I need to make cubic behavior here. So kind of a parabola here, parabola there. Okay. Then we're going to go to the 1. Order 1. So we're just going to pass through. But at the same time, we have to pass through this y-intercept. All right. Then we go to the next one. Next x-intercept has order 1, pass through. And it is done. All right. Now, writing the equation of a function. Why do you curve it at the end? Here? I didn't curve, so I just go straight with a slope a bit. Here? Because you have to, after x equals 1, x-intercept, there is another x-intercept 3. So you have to curve back to there. And it is linear behavior here because order 1. This end is curved, yes, right? This part is curved because you make cubic behavior here. X plus 2 has a power of 3. You make a cubic behavior. No, it never looks like absolute value function. Absolute value function has straight lines. Okay, polynomials are except the lines, linear functions. They are all curves, right? They are curves basically, not lines. So when we say linear behavior or cubic behavior or quadratic behavior around x-intercepts, we mean around the x-intercept. So you have the cubic behavior around this x-intercept, not the whole thing, just around the x-intercept, okay? Or we have linear behavior around, let's say here, 1, linear behavior. When you look at in that small region, you see it as a line, but not the whole thing is line, just around the x-intercept. Is it clear? Okay. Now we are going to write an equation. If the graph is given, what do we do, right? So y equals, first we're going to look at the x-intercepts, right? So we have -3, so that gives us a factor x plus 3. Then check the behavior of the graph around that x-intercept. I see linear behavior here, so it is order 1. Okay, so we go and check the next x-intercept, -1. That gives us a factor x plus 1. Then you check the behavior of the graph. So it is linear behavior, right? In that small region, it looks like a line. So order 1. Okay, then we go to the next x-intercept, 2. That gives us factor x minus 2. Then you check the behavior of the graph around that x-intercept. It is parabolic behavior, right? It is not passing through linearly, but it is making a bounce here, right? It is bouncing. It's not even passing through the x-axis. It is bouncing off the x-axis. So, and if you look at in that small area, it's like the vertex of a parabola. Therefore, it is called parabolic behavior. So we put 2 there. But of course, we need to calculate the leading coefficient here, A. Okay. How are we going to do that? We are going to use a point from the graph. In this case, this point is here. X coordinate 0, y coordinate -6. That is the y-intercept. But it doesn't have to be the y-intercept. It can be any other point on the graph that has integer coordinates. So now we are going to substitute this point in the graph. Okay. Substitute 0 and -6. Y value is -6. A, x is 0. Okay, that's what we get. So -2 squared is 4. 4 times 3 is 12. So -6 equals 12a. Divide both sides by 12. So you get a being -1/2. So the equation is -1/2 x plus 3 x plus 1 x minus 2 square. The places of the factors do not matter. You can put these orders in any way. Okay, it is okay to write x minus 2 squared times x plus 3 times x plus 1. That doesn't matter.
Miss, why is a -1/2?
Because we get -6 equals 12a. Divide both sides by 12.
Yeah. Okay.
Okay.
Okay, thank you. Yep.
Okay, moving on. Another example, writing the equation. Okay. Of course, there's arrows at the end. So y equals, we are going to do the same thing, a times. So look at the first x-intercept. What is it? 0. What kind of behavior do you see around that one? It's cubic behavior. So 0 gives you x, but because there's cubic behavior, you put exponent of 3, so x cubed. Next x-intercept, you go here, 3. That gives you x minus 3. Check the behavior of the function. Parabolic behavior, bounces off. So that factor gets power of 2. Then you go check next x-intercept, which is 4. That gives you x minus 4. Check the behavior of the graph. Linear, it's just passing through. Then you go and find the next x-intercept, which is 5. And then again check the behavior of the graph. It is linear behavior. So power of 1. Now you are going to substitute a point. This point is given to you, right? It is very clear, 2 and 12. Okay, let's substitute that. So 12, a, 2 cube is 8. 2 minus 3 is -1. -1 squared is +1. 2 minus 4, -2. And 2 minus 3 is -3. So you get 48. A. Divide both sides by 48. 12 over 48 is 1 over 4. Then the equation is y equals 1 over 4 x cubed x minus 3 squared x minus 4 x minus 5. All right. A set of polynomial functions. Yeah, we are going to look at the next one. Is there any question about writing the equation from the graph before we move on? So when you turn the page, you have lots of practice, okay, for writing the equation from the graph. Okay, let's look at the next one. Family of polynomials. A set of polynomial functions whose equations have the same degree and whose graphs have common characteristics. For example, they have the same x-intercepts, okay? Example 6. Write an equation of a quintic function that has a double root at -1 over 2, single root at 1, 3 over 2, and 2 over 5. And y-intercept is 6. Okay? We're going to write the equation. So again, A goes here. They are telling you that there's a root at -1 over 2, right? So are we going to write x plus 1 over 2 as a factor? So you already learned in grade 11 the factored form of parabolas. Try to remember those, parabolas, quadratic functions in factored form. Have you ever seen any fraction in the factors? I mean, you can see a as a fraction, but actually, you should never have fractions in the factors itself. So what do? We need to get rid of it. Okay, the easiest way: look at the denominator, multiply both terms with the same denominator. Okay, so that is 2. Multiply these two terms by 2, so you end up with 2x plus 1. Okay, and then we have next factor. This has double root, so you put square. Let's go to the next x-intercept or root 1. That gives you x minus 1. Look at the next one, 3 over 2. So x minus 3 over 2. Again, I cannot have fraction here. So multiply both terms by 2. You get 2x minus 3. Okay. If you can directly see it, then, you can directly write that way. 2x minus 3. So next one is 2 over 5. Again, so if you have x minus 2 over 5, get rid of the fraction. So multiply both of them by 5. You get 5x minus 2. Okay. Now we are going to solve for A. So a point is given to you, y-intercept. So then x coordinate is 0, y coordinate is 6. So then 6 equals A. 1 squared is 1, -1, -3, -2. So we get -6 here. So 6 equals -6a. Divide both sides by -6 to get a equals -1. Then the equation is y equals -2x plus 1 squared, x minus 1, 2x minus 3, 5x minus 2. Example 7. Each member of a family of cubic functions has zeros -2, -1, 2.5. So write the equation of the family. State two functions that belong to this family. So y equals a. So intercepts x plus 2 minus 1 gives you x plus 1. Positive 2.5 gives you negative x minus 2.5. But again, we cannot write with decimal or a fraction. So 2.5, you can write it as 5 over 2. And if you multiply both terms by 2, you get 2x minus 5. Okay? 2x minus 5. All right. So that is the equation of the family. As you can see, there is infinite number of equations, okay, that you can get from here. They all belong to the same family. They all have the same x-intercepts. We say state two functions that belong to this family. So you can just make up some a values. Okay, so I'm gonna just say maybe 6, x plus 2, x plus 1, 2x minus 5. Or maybe I'll just say -5, x plus 2, x plus 1, 2x minus 5. Next question. Determine the equation of a member of the family that passes through 1 and 36. Now there's only one answer for this, right? You're just going to take this, but then you're going to calculate the a value using this point. So there's only one answer. All right, so again, we are using this one. So we are going to substitute 1 for x, 36 for y. 36 equals 8 times 3. 1 plus 1 is 2, and that gives you -3. So 3 times -3, -9, -18. -18a. Divide both sides by -18, you get -2. So y equals -2, x plus 2, x plus 1, 2x minus 5 is the answer.